Okay, what we've got here is a Flo Torq II Mercury propeller hub system. It consists of, obviously, the propeller. Now, it's already got a hub in there. I'll knock that out. Okay, we'll get that one out of there. Okay, so start with the Delron sleeve. This transfers power between the hub, which goes onto the propeller shaft, goes in there, and then the propeller, which goes over the outside of that. So that's how thrust is transferred, through this plastic sleeve. Should there be an impact or something like that, the sleeve will actually strip out. Then as it's spinning, it gets hot and starts to melt. When you stop the boat, the sleeve re-solidifies and allows you to get home again. Or you can just pop it out and throw a new one in. Brass sleeve. Now this is the part that changes between the different spline shaft, propeller shafts. So again, that goes in there. We've also got, very importantly, a thrust hub. A couple of different thrust hubs here. They're effectively the same hub. You can see there that their inside diameters are the same, outside diameters are a little bit different, and the shoulder for the propeller shaft is the same. We have a lock nut, a lock tab, and a grounding washer. The grounding washer is actually quite important. We also have, most importantly, the propeller. This is the outer hub, this is the inner hub. The way we assemble it, or what happens, the sleeve goes in, which I'll put in a minute. The thrust hub goes inside the front of the propeller like that, so that the thrust of the propeller, hence the name thrust hub, pushes hard up against the hub. The hub is the interface between the front of the propeller shaft and the propeller. There's a tapered inside diameter on the thrust hub that runs hard up against the front of the propeller shaft. Now, some propeller shafts don't have a taper, it's a hard shoulder, in which case this would be a hard shoulder as well. But that sits hard up against there. Now I'm going to leave the sleeve out for a minute, turn the propeller over, and see the back of the propeller, the drive hub slides into there and goes hard down on the propeller. So there's no room, once we then, if the propeller shaft is out there, we'd run this down, we'd tighten it up, and between the brass sleeve and the thrust hub, the propeller is clamped. So the propeller's held there. The taper on the propeller shaft holds the thrust hub. The sleeve is too short to bottom out, so what you've got is a clamping effect. There's no movement. When we put the Delron sleeve in, nothing changes. The sleeve runs down inside the hub. You push that down, you can see it's actually run down quite a long way. That still goes on there and presses hard against the hub. We turn this over, we drop this in, you can see the four keyways, drops in there, and again presses hard on the propeller. Sorry, not that. We have the grounding hub, that goes there. Sorry, the grounding ring there, and that creates the continuity between the propeller shaft, the brass hub, and the body of the propeller. So you've got continuity. The nut also then goes on, spins down, and again tightens up so that we are clamping the thrust hub, the propeller, and the brass hub all clamped together. There should be no movement of the propeller itself on the propeller shaft. You will be able to move the propeller, but that is the shaft actually moving in the gearbox, which is normal. You get up to 1/4 of an inch of movement depending on which particular gearbox. Some of them it's only as small as 1/8, others it's as much as 1/4 of an inch. But once that's tightened down, if you've got the right thrust hub, and be careful, there are different thrust hubs, some of them are not right. The right thrust hub sits hard against the shoulder on the inside of the propeller.